In section 2.3, we talked about the theorem that regards the inverse of a product. So if A and B are invertible matrices of size n, then AB is invertible, and AB inverse is B inverse A inverse. So we'll begin this proof by assuming that A and B are invertible matrices of size n. Then we will need to show that there exists a matrix C such that when you multiply on the left by C or on the right by C, you will get the identity. So first let's define C, what we would like that to be. C will be B inverse A inverse. And let's look at the right multiplication. So we would like to multiply C on the right, so we could multiply A, B, and C. We've defined C to be B inverse A inverse. Now when we do this, what we can see then is B times B inverse. Because B, we've made the assumption that B is invertible, this will become the identity. Okay. So the justification here is that B is invertible. We did that by the assumption. Okay. And we assumed that because at the beginning of the theorem starts out if A and B are invertible. So we will make that assumption and use it in the proof. Okay, so once we've done that, we have the identity in the middle. We can associate this because matrix multiplication does associate. We know then that this will just become A because this step is justified by the identity. This is multiplication by the identity matrix. Then lastly, we can use the fact that A is invertible, and so we can say that this is equal to then the identity because A is invertible by assumption. Okay. So that shows it on the right. We can make the similar argument on the left with the reasonings. You can just say similarly on the left, and then consider what would happen if you multiplied C on the left of A and B. We've defined C to be B inverse A inverse, then that multiplies by A and B. So just working it around, again, A is invertible, so we'll get the identity with B inverse B. You can associate, it doesn't matter which ones you pick. B inverse times the identity will be B inverse times B. And lastly, by the assumption that B is invertible, B inverse times B must be the identity. And then we can draw our conclusions. So therefore, by definition of inverses, C, which we've defined to be B inverse A inverse, is AB inverse. And then we can just say it more explicitly using the equal sign. So AB inverse is equal to B inverse A.